Good evening, students. Today our topic is Paper-VII, Unit 10. Today our topic is Paper-VII, Unit 10, that is biosynthesis by aromatic hydrocarbons, biosynthesis aromatic hydrocarbons by acetate, malonite, and chimic acid pathway. Biosynthesis aromatic hydrocarbons by acetate, malonite, and chimic acid pathway. First one is biosynthesis of aromatic compounds. Biosynthesis of aromatic compounds. The biosynthesis of aromatic compounds by acetate malonite pathway. Biosynthesis of aromatic compounds by acetate malonite pathway. Okay, when this biosynthesis of aromatic compound by acetate malonite pathway. So when we take acetate means we are take acetyl CoA, and malonite pathway means malonite CoA. We are taken malonyl CoA. Two starting materials are taken. It is acetyl CoA, malonyl CoA. That's why this is called acetate malonite pathway. Okay, when acetyl coenzyme A or CoA, when reacting with malonyl coenzyme CoA, so they forms polyketates. The polyketide undergo cyclation. They forms aromatic compounds. The polyketones undergo polyketates undergo cyclation. They forms aromatic compounds. Okay, so see how do they forms aromatic compounds here? Biosynthesis of polyketates. In this case, biosynthesis of polyketates. Biosynthesis of malonyl CoA. Biosynthesis of malonyl CoA means when we take ATP is undergo enzymatic hydrolysis. ATP undergo enzymatic hydrolysis. They forms ADP and phosphoric H3PO4 phosphoric acid. ADP plus H3PO4 formation takes place. When ATP undergo hydrolysis, they produce ADP and H3PO4. This H3PO4 undergo reacting with the biocarbonate. When reacting with biocarbonate, they forms that here negative charge attack at phosphorus. This pi bond shifting to oxygen side, then forms a bond formation between negative charge of oxygen and phosphorus. Okay, now it is involved in loss of water molecule. Then forms mixed hydrates. They forms mixed hydrates. These mixed hydrates, when reacting with biotin enzyme complex, this is a biotin enzyme complex. When reacting with mixed hydrates, undergo last this here the carboxylic acid group is shifting to nitrogen. This carboxylic acid group shifting towards nitrogen side, then forms N-biotin carboxylic acid, N-biotin carboxylic acid. So when this is there, okay, then fourth one, this N-biotin carboxylic acid reacting with acetyl CoA. When this is the N-biotin carboxylic acid reacting with acetyl CoA, then forms here, that is a biotin, then forms acetyl CoA carbon ion. The acetyl CoA carbon ion reacting with another mole of biotin enzyme complex here. This is a biotin carboxylic acid. This biotin carboxylic acid then forms malonyl coenzyme A. They forms malonyl coenzyme A. This is the malonyl coenzyme A. This malonyl coenzyme A plain again when under same biotin enzyme complex will be regenerated. This is a malonyl coenzyme A. Okay, so when formation of polyketates. Formation of polyketates we are discussing formation of polyketates when acetyl coenzyme A. When acetyl coenzyme A reacting with malonyl CoA. Acetyl CoA reacting with malonyl coenzyme A undergo loss of carbon dioxide. It is undergo loss of carbon dioxide. The bond formation between acetyl CoA carbon and another mole of acetyl carbonyl, they forms acetyl CoA. This is acetyl CoA. This is acetyl CoA. This is a diketide. When this diketide reacting with another mole of malonyl coenzyme. When reacting with another mole of malonyl coenzyme, they forms tetraketed and tetraketed, then continuation reaction, then forms polyketide. It is a product. When the polyketide undergo so for folding on the surface of enzyme, the polyketates undergo goes folding on the surface of enzyme. Folded polyketide undergoes cyclation by intramolecular cyclation and intramolecular condensation and Claisen condensation. So that polyketates undergo intramolecular condensation and Claisen condensation. They forms aromatic hydrocarbons. So we are discussing different aromatic hydrocarbons from polyketates. This is a biosynthesis of orsenic acid. Biosynthesis of orsenic acid. This is a orsenic acid. Benzene containing 2 hydroxy groups, 1 methyl, 1 carboxylic acid. This is orsenic acid. This is biosynthesis of orsenic acid from polyketide. So polyketide. Okay, when this is the mechanism. So when acetyl-CoA, when reacting with malenyl-CoA, diketide. Acetyl-CoA reacting with malenyl-CoA, they forms diketide. This diketide reacting with another mole of acetyl-CoA, they forms triketide. Continuationally, we have to need to produce tetraketide. This tetraketide undergo folding on stereospecific surface of the enzyme. This tetraketates undergo folding on surface of stereospecific surface of the enzyme. Then followed by intramolecular allyl condensation. Followed by loss of water molecule, then forms orsenic acid. This is orsenic acid. Orsenic acid is a product. Okay, that means we have to synthesize tetraketide. This tetraketide undergo folding on stereospecific surface of the enzyme. So the undergo structure reorganization takes place. Then followed by intramolecular allyl condensation. Then forms what is our orsenic acid is a product. When this orsenic acid, when reacting with ATP in terms of TPP, thiamine pyrophosphate, they forms orsinol is the product. Next one is biosynthesis of acetyl fluoroglucinol. Biosynthesis of acetyl fluoroglucinol. This is acetyl fluoroglucinol is the product. This is the acetyl fluoroglucinol. So in this acetyl fluoroglucinol, again we have to synthesize tetraketide. From acetyl-CoA, 3 moles of malenyl-CoA and produces tetraketide. Acetyl-CoA 1 mole, 3 moles of malenyl-CoA, they produces tetraketide. This tetraketide undergoes cyclation, then form acetyl fluoroglucinol. So mechanism here, you have to synthesize tetraketide from 1 mole of acetyl-CoA, 3 moles of malenyl-CoA. They forms tetraketide. This tetraketide undergo folding on the stereospecific enzymatic surface. So then followed by intramolecular allyl condensation. Then forms this is the acetyl fluoroglucinol is the product. Next, biosynthesis of xanthines. Biosynthesis of xanthalenes. Biosynthesis of xanthoxylenes. This is xanthoxylene. We have to biosynthesis of this xanthoxylene from 1 mole of acetyl-CoA, 3 moles of malenyl-CoA. So 1 mole of acetyl-CoA, 3 moles of malenyl-CoA, then produces tetraketide. This tetraketates undergo folding on the enzymatic surface, followed by intramolecular condensation, then forms acetyl fluoroglucinol. This acetyl fluoroglucinol, when reacting with 2 moles of SAM, then produces Xanthoxylin is the product. Xanthoxylin is the product. So next, biosynthesis of 2-methoxy 5,7-dihydroxycoumarin. 2-methoxy 5,7-dihydroxycoumarins. For the synthesis of this 2-methoxy 5,7-dihydroxycoumarin, so again we take 1 mole of acetyl CoA, 4 moles of malonyl CoA. They produces pentaketide. Then produces pentaketide. Okay, 1 mole of acetyl CoA, 4 moles of malonyl CoA, then produces pentaketide. This pentaketide, this is a pentaketide. This pentaketide undergo intramolecular aldol condensation. Intramolecular aldol condensation. Intramolecular aldol condensation. They forms a cyclic ring followed by cyclation. Cyclation then produces 2-methoxy 5,7-dihydroxycoumarin. 2-methoxy 5,7-dihydroxycoumarin is the product. Okay. Next, biosynthesis of E-genose. Biosynthesis of E-genose is a synthesis of biosynthesis of E-genose when 1 mole of acetyl CoA, 4 moles of malonyl CoA, then produces again pentaketides. This pentaketide undergo same concept, intramolecular aldol condensation. Intramolecular aldol condensation, a double bond will be formation. The ring will be formation takes place. This ring, when this ring in this ring, that hydroxy group, this coenzyme will be removed by the hydrolysis. Hydroxy group is added, and this compound when react with SAM, that hydroxy, all 3 hydroxy groups are undergo methylation. All 3 hydroxy groups are undergo methylation, like this. Next, biosynthesis of alterenol. This is a structure of alterenol. When this 1 mole of acetyl CoA, 6 moles of malonyl CoA, then produces 6 plus 1, 7 heptaketide. 1 mole of acetyl CoA, 6 moles of malonyl CoA, they produce heptaketide. This heptaketide undergo intramolecular aldol condensation. Intramolecular aldol condensation. So intramolecular aldol, 2 moles of 2 times of intramolecular aldol condensation. 2 times of intramolecular aldol condensation here and here. 2 times of intramolecular aldol condensation. 2 times of intramolecular aldol condensation. 2 rings are the formation takes place here. 2 rings are the formation takes place, and then followed by loss of water molecule. Loss of water molecule. Then forms our alterenol is a product. Next, biosynthesis of terpenoids by malonyl pathway. Biosynthesis of terpenoids by malonyl pathway. Biosynthesis of terpenoids by malonyl pathway. We know already terpenoids means isoprene. So terpenoids are the polymers of isoprenes. That structure, this molecular formula is C5H8 is the terpenoids. C5H8 is a terpene as isoprene. C5H8 is isoprene. Terpenoids are polymers of isoprenes. C5H8 taken to the power of N. Okay. So this is a molecular formula C5H8. Isoprene is the C5H8. So terpenoids are the polymer of isoprenes. That means we take N. We will take 1, 2, 3, 4, etc. So that is based on the number of N, the number of N's, we can terpenoids are classified into different types. If N is equal to 1, hemiterpene, the number of carbons are 5 because C5H8N. If N is equal to 1, hemiterpene, the number of carbons 5. Only one isoprene unit is there. And N is equal to 2, monoterpene, 2 means we'll take 2, 5, 10 carbons. And if it's N is equal to 3, sesquiterpene, 15 carbons, N is equal to 4, diterpene 20 carbon atoms are there. So like this we have to take in here. So again, lot of are there. And if it is called 5, terpene, 6 tetraterpene, 7 6 triterpene, 7 tetraterpene, 8 polyterpene, 9 rubber. Okay, natural rubber is a rubber. That is rubber also polymer of terpenes. Okay, this is a malonic acid structure. This is a malonic acid. This is malonic acid. What is 3,5-dihydroxy? 1, 2, 3, 4, 5. 3,5-dihydroxy. 3,5-dihydroxy, 3-methyl, 3,5-dihydroxy, 3-methyl. Pentanoic acid is a malonic acid. Malonic acid. So that is biosynthesis of malonic acid. Now we have to synthesize this malonic acid. First one, biosynthesis of malonic acid. For the biosynthesis of this malonic acid, acetyl-CoA, malonyl-CoA. Acetyl-CoA, malonyl-CoA, they forms a monoterpene, monoketide, then this monoketide. This is a monoketide. This is a monoketide. This monoketide undergo reaction with acetyl this is a monoketone, that his name is acetyl coenzyme A. This acetyl coenzyme A, when reacting with another mole of acetyl CoA, then forms this this carbonyl compound under hydrolysis, hydroxyl group converted to hydroxyl group, then partial hydrolysis. So partial hydrolysis, we have to get now remove of this coenzyme A and converted to carboxylic acid, and then forms 3-hydroxy-3-methyl glutaraldehyde CoA. 3-hydroxy-3-methyl glutaraldehyde CoA. This compound undergo conversion to reduction takes place, then forms malonic acid. Now this is the malonic acid. Next one is from this malonic acid we have to synthesize different terpenes. So that is biosynthesis of hemiterpene. Biosynthesis of hemiterpene. Hemiterpene means only 5 carbon atoms are there. Biosynthesis of hemiterpene from malonic acid. When this malonic acid, when reacting with ATP, they convert into ADP. This one of the hydroxy group undergo phosphorylation takes place. Hydroxy group undergo phosphorylation takes place. Now this phosphorylated group undergo some decarboxylation. They forms isopentyl pyrophosphate. Isopentyl pyrophosphate is the product. This isopentyl pyrophosphate under hydrolysis they form C5 carbon, that is hemiterpene. They form C5 carbon hemiterpene. That name is 3-methyl 2-butene 1-ol. 3-methyl 2-butene 1-ol. 3-methyl 2-butene 1-ol is the monoterpene. Okay, this is one of the best method to synthesis of hemiterpene. Next, biosynthesis of acyclic homoterpenes. Next one, biosynthesis of acetyl hemiterpene terpenoids. Biosynthesis of acyclic hemiterpenoids. This biosynthesis of acyclic hemiterpenoids when when 3 moles of acetyl CoA when converted to isopentenyl and then geranyl, this is geranyl pyrophosphate. This is geranyl pyrophosphate. This geranyl pyrophosphate undergo hydrolysis. They forms geranyl. This is a homoterpenoid. This is a homoterpenoid geranyl. Okay, this is a structure of geranyl. This is one example for homoterpene. Next, biosynthesis of monocyclic homoterpene. Biosynthesis of monocyclic homoterpene, that is alpha terpenal. That is alpha terpenal and beta terpenal. Examples: when geranyl and nerol, geranyl and nerol, when geranyl and nerol, geranyl or nerol undergo uh, uh, loss of water in presence of acid medium, loss of water molecule takes place. They forms LLE carbocation. This LLE carbocation is stabilized by converting to tertiary carbocation. This tertiary carbocation undergo loss of proton. They forms a unsaturated compound, that is monocyclic monoterpene. Monocyclic monoterpene is a formation take place. The name is limonene. Limonene is the product. This positive charge undergo hydrolysis. When react this tertiary carbocation compound reacting with water molecule, then forms alpha terpenal. This alpha terpenal under hydrolysis, they forms dihydroxy compound. When reacting with acid medium, then forms beta terpene. Beta terpenal is a product. This is a monocyclic monoterpene. This is a monocyclic monoterpene. Okay. This is example. Next, biosynthesis of bicyclic monoterpene. Biosynthesis of bicyclic monoterpene. Best example is alpha pinene. So already we know geranyl or nerol under hydrolysis when reacting with the acid medium, loss of proton and LLA carbocation takes place. This LLA carbocation, when shifting of pi bonds, they forms tertiary carbocation. This tertiary carbocation is unstable. Again converted into a cyclic tertiary carbocation formation takes place. The carbocation, tertiary carbocation in the form of ring, they undergo reorganization. They forms the carbocation and ring formation takes place. Then undergo loss of proton. Alpha pinene is the product will be formation takes place. So this is alpha pinene. So another example for camphor. Another example is camphor. Bicyclo monoterpene is camphor. Same here, tertiary, neryl or geranyl under loss of proton, loss of water molecule, then LLE carbocation. This LLE carbocation is shifting into converted to tertiary carbocation. This tertiary carbocation is under cyclic tertiary carbocation. This carbocation is converted to in the form of ring, shifting into ring, then followed by hydrolysis, then followed by oxidation, then forms camphor is the monocyclic bicyclic homoterpene. Bicyclic monoterpene. Okay. Next one is biosynthesis of sesquiterpenoids. Biosynthesis of sesquiterpenoids. Biosynthesis of sesquiterpenoids. This is that when 3 moles of acetyl CoA, 3 moles of acetyl CoA, when converted into Sorry for the disturbance. When 3 moles of acetyl CoA and then converted into malonic acid 3-phosphate 5-pyrophosphate 3-phosphate 5-phosphate. Now it is converted into isopentyl pyrophosphate. Now it is again rearranged to dimethyl allyl pyrophosphate. Now isopentyl pyrophosphate plus dimethyl allyl pyrophosphate. Isopentyl pyrophosphate, dimethyl allyl pyrophosphate, and combined they forms geranyl pyrophosphate. So now this is that. Now we are taking, this is the geranyl pyrophosphate. So we are seeing this is a sesquiterpenates. So this is a geranyl pyrophosphate. This is geranyl pyrophosphate. When the geranyl pyrophosphate reacting with another mole of pyrophosphate, then followed by cyclation, then forms these are the sesquiterpenates, beta ferrophenols and alpha ferrophenols. Next. Next, this is important. Next, biosynthesis of aromatic hydrocarbon by chimic acid pathway. Biosynthesis of aromatic hydrocarbon by chimic acid pathway. This is very, very important. Biosynthesis of aromatic hydrocarbons by chimic acid pathway. This is a chimic acid. This is a chimic acid. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 3 alpha 4, 3, 4 alpha 5 beta trihydroxy cyclopentene carboxylic acid is the chimic acid. Now going to biosynthesis of chimic acid. We are going to biosynthesis of chimic acid when pyruvic acid undergo inhalation, then reacting with ATP, then forms phosphopyruvic acid. Phosphopyruvic acid is the formation takes place, and erythrose 4-phosphate is the product. Erythrose 4-phosphate is the product. So now it is undergo cyclation. Now it is undergo different cyclations. We are getting directly, we are getting chimic acid. We are getting chimic acid. This chimic acid is one of the starting material in the synthesis of different aromatic hydrocarbons. Biosynthesis of aromatic hydrocarbons from chimic acid. Biosynthesis of aromatic hydrocarbons from chimic acid. This is chimic acid. Chimic acid, when reacting with ATP, they convert into ADP. So when hydroxy group undergo phosphorylation takes place, then forms phosphorylation takes place. Then reacting with phosphophenol pyruvic acid. Then reacting with phosphophenol pyruvic acid. When reacting with phosphophenol pyruvic acid, then forms. Then forms here attacking takes place. Then followed by 5-enol pyruvyl chimic acid 3-phosphate. 5-enol pyruvyl chimic acid 3-phosphate. This is the compound. This compound, when undergo conversion takes place, different conversions, they forms different phenyl pyruvic acid and phenyl pyruvic acid and para-hydroxyphenyl pyruvic acid is the formation takes place. Next one, this is a phenyl pyruvic acid. This is a phenyl pyruvic acid. When reacting with glutamic acid, they forms the carbonyl compounds undergo amination. They forms phenylalanine, and this is a different aromatic hydrocarbons are synthesized in the different way. Next, biosynthesis of so I'm given everything notes. Okay, but next, biosynthesis of anthralinic acid from chimic acid. Biosynthesis of anthralinic acid from chimic acid. When this chimic acid, when we undergo phosphorylation followed by reacting with pyrophospho pyruvic acid, pyrophosphopyruvic acid, then followed by some cyclizations, then forms anthralinic acid is the product. Anthralinic acid is the product. So this is a biosynthesis of tryptamine from chimic acid pathway. These are the biosynthesis of different one.